All right, we are starting our second chapter now, which is all about functions. So the first thing I wanted you to do in your warm-up was to name the ordered pair for each point, okay? What makes up an ordered pair? There's two pieces. An X and a Y, good. So we need X's and we need Y's, right? My X's, are they horizontal, side to side, or are they vertical, up and down? They are horizontal, right? On this side is our positive X's. On this side is our negative X's. There we go. And that means my Y's are where? They're where? They're vertical. It's freezing. Y is going to be vertical. So positive Y goes up, negative Y goes down. Okay? What if you're on the exact axis that we're looking at? There we go. So like E, the first one they're asking for, okay? Here we go. So starting from the origin, right, this is 0, 0. To get to E, we move to the left how many units? 1, 2, 3, 4, right? Do we go backwards 4 or forwards 4? We went backwards, right? So what X value is that? If I started at 0 and went backwards 4, what is that number going to be? A negative 4. Okay? Did I go up or down? No, I only moved over to the left, right? So if I didn't go up and down, my Y value is still a what? It's still a 0. So that point is negative 4, 0. All right, how about F? Where's F? F is down here. So to get from the origin to get to point F, how am I going to move to get there? So I had to go backwards again, right? 1, 2, 3, 4, 5. I went backwards 5, which I'm going to show what for my X? That becomes negative 5. Good. And then I went down 1, 2, 3, 4, 5. So down 5 is another negative 5. Coming back to you, hopefully. All right, now we're going to G. So we always start from the origin of that point 0, 0. How do I go from the origin to go to point G? We only go up. So what's your X value? Still a 0. We didn't go left or right. We only went up. And we went up how many? 4. So my Y value is 4. All right, let's go to H. Where is H? Okay. So they're not always pretty, right? Or on whole lines. H is kind of in the middle of something, right? So to get from my origin to get to H, it looks like I went over 1, 2.5. Would you agree with that? So not really 3, but not really 2. It's in the middle of 2 and 3. Yes? So we can make our best guess and say that's what, 2.5 or 2.5 for my X value? And then how about the Y's? So how far do we go down? 1, 2, 3, and then a little bit more? So we went down about 3.5? So how do I say down 3.5? Is it positive or negative? Negative. So then we went down 3.5. All right, let's go to J. We'll do blue. J is up here. So how do we go from the origin to get to J? Do we go left or right? Start with that. We went to the right. And we went to the right how many? We went to the right 3. So that's going to be a positive value of 3. And then we had to go up or down? Up. We went up how many? 3. So that's another positive 3. So negative Y's show down, positive Y's show up. The zeros showed it didn't move up or down, okay? Negative x's show that they moved to the left. Positive x's show that we moved to the right. And again, an x for a 0 shows we didn't move left or right. So if you want to put those little arrows on there to kind of help remind you just what does negative and positive mean, put them on there. Okay. So this is important because today we're going to talk about what is a function or what is not a function, and we're going to have to look at the x's and the y's, or the domain and the range. Do those words sound familiar? Domain and range. We've at least heard of them before. Yeah? Okay. So your domain is going to be all of your x values, and your range will be all of your y values. So if someone asks you for the domain of this scatter plot, you would say -4, -5, 0, 2.53. You would just list all the x's. Okay. If they wanted the range for this scatter plot, you would list all the y's. 0, -5, 4, -3.5, and 3. Okay. So I'm going to refer to domain and range a lot today. Okay. So equations that are functions can be written in a form called function notation. Okay. Function notation. So what this is that we use f of x instead of saying y equals. Okay. It's the same thing. You're probably used to saying y equals and then some kind of equation, right? Function notation, we change it. We say it out loud, f of x. Okay. In a function, x represents the elements of the domain and f of x represents the elements of the range. Okay. The graph of f of x is the graph of the equation y equals f of x. Okay, so again, we're going to put down some reminders so we remember when I talk about domain, that's going to be your x values. And when we talk about range, that's going to be your y values. I might mention the words input and output today also. So we usually plug in the x and we get out the y. So if I mention input, output, make sure we know which one of those correlates with what also. So to show f of x shows we plug in x into my function because x is in parentheses. That's what we're going to plug in. Later that x might change into a number. So we're going to change all of my x's to what that number is. So that's why it's just written in that way. We good? Ready to talk about what makes a function? Are we okay with this vocabulary? We have it written down so we can go back to it if we need to. Okay. Finley, you got it? Okay. A pairing of one set of input numbers, which is called the domain, and another set of output numbers, which is called the range, is a relation. So if I have x's and y's in any way, shape, or form put together, it's called a relation. Okay? A function is special. That's when there's only one output for each input. Okay? The relation is shown a function because each element of the domain is paired with exactly one element of the range. That is very fancy for your x's don't repeat themselves. Okay? X's never repeat. Okay, so if I have a bunch of points and I write them out, as long as each x is its own, it is considered a function. That's what makes it special. Okay? X's cannot be used twice. So here's some examples of what we're going to see. The first one's called mapping. So my domain, these are my x values, these are my y values. See how each domain only has one arrow coming off of it? That's good, okay? If one of my domains had two arrows coming off of it, that means the x is being used twice. That's bad, okay? I really don't care what's happening in the range. We can have multiple x's go to the same y. That's fine. If they all went to a y of 4, that just means we have a horizontal line at 4. Okay? The y's are not going to determine, there we go, if we have a function or not. We care about my x's. Okay? When we have a graph to look at, there's a test we're going to do. And the test is called a vertical line test. Okay? So these graphs are both relations. Okay? A relation is a function if it passes the vertical line test, meaning a vertical line intersects the graph no more than one time. So if I took a vertical line, which is up and down, right? And I kept drawing it over and over and over, it's never going to touch that graph more than once. So it would pass. Sometimes people take their pencil and they kind of slide it across the graph. So here, if I took my ruler and I went across, see how it never touches it in more than one spot? Okay, but look at this one over here. Uh-oh, it's touching twice, right? See how it's touching my vertical line in two different spots? As I slide it over, that's bad. So it's a relation. We have x's and y's, but it's not considered a function. Okay, so if you draw a line and it hits twice, it is not a function. Yes, no, maybe? Kate, you can slide over if you want to. You can always slide over if you want to. You don't have to. It's up to you. Okay. Okay, so mapping, we look at my x's, make sure they all only have one arrow coming off of it. And if we have a graph, we check vertical lines, make sure it doesn't cross over a vertical line to different spots. All right? So let's determine. Let's look at this first mapping down here. My domain, -4, -2, 2, 5. Range is -1, 3, and 6. What do I care about, domain or range? We care about domain only. So let's just look at this. Do each of my domains have exactly one arrow coming off of them? Yes. So is it a function? Yes. Okay, so yes. Each x is only being used once. Okay, there's only one arrow. So each value on that domain in my mapping only has one arrow coming off of it. We're good to go. How do we feel? Okay. My next example is a table, and it has my domain and my range listed. Which one do I care about? I only care about domain. I don't care about the range. I care about this top piece right here. Are any of those numbers repeating themselves and being used more than once? Yeah, which one? 2. The 2, right? So because those are repeating, this is a no. You cannot have x's repeat. That is bad. All right, and then part C gives me a list of all of the points. Okay, so we just kind of graphed these. Which one of those numbers is the x number? Is it the first or the second in each pair? It's the first one. So we're only looking at the 2, the 4, the 8, and the 4. Those are the only ones I care about. Did any of those repeat themselves? The 4 did, right? Uh-oh. So because it repeated, is this a function? No. These are all relations, okay? If you have an x and a y, it is a relation. Function is special. That's when the x's don't repeat themselves. That's my knee. Did you hear that? Don't get old. Okay. So on the back at the top, I have another mapping, we have another table, and we have another set of ordered pairs. I want you to determine which ones are functions and which ones are not. So you try it on your own, try it with your partner. We'll pause and come back, so just figure out which ones are functions. Okay, number 1, what did you look at? The domains or the ranges? Just your domains, good. Do you like them? Do any of them have more than one arrow coming off?
No.
Nope, they all have only one arrow coming off. So, is it a function? Yes, this one is a function. All right, so we know that's gone. One has to be included. All right, so we like 1. Relation number 2. So my domain is 0, 2, 4, 0, -2. My range is 8, 6, 3, -1, -3. What did you focus on? Just your domain. Good. And what did you see? You have 2 of what number? You have 2 zeros, right? Uh-oh. That's okay. Now, there is a 2 and a -2. Is that the same number?
No.
It's not the same number, so that's okay. Okay. The issue is there was 2 different zeros. So, is this a function? No. Wah, wah. So, 2 is out. So, I think we have our answer, but let's just double check. Number 3. What did we focus on? The first number or second number or both? Just the first number each time, right? Because it goes X, Y. So we looked at just -4, -2, 1, -2, and 5. Is it a function? No, why not? There we go. Our -2s. We have 2 -2s. Therefore, it is not a function. So yes, relation A is the only one that is also a function. So that's when the information is given to you already mapped out. Sometimes we got to pull information out of a description. Okay? So we have to determine what is domain and what is range. So let's do the long jump first. Okay? Long jump. Here we go. 5 schools are competing in the long jump portion of a track meet. The distance of the players with the best jump on each team are as follows. Team 1 went 20.6 feet. Team 2 did 21.5 feet. Team 3, 20.9 feet. Team 4, 19.4 feet. And Team 5, 20.2 feet. Okay, so we need to figure out, is this a function or is it just a relation? Okay, the way we do that, let's make a table. Okay, let's map them out. So we have teams and we have distance. Yes? You with me? And that's how they're all kind of separated? Yes, Miss Douglas. So, here we go. We have teams. Come on, pen. There we go. And we have their jumps. Okay. So, team 1 jumped 20.6 feet, right? Team 2 went 21.5 feet. Team 3 went 20.9 feet. Team 4 did 19.4 feet. And Team 5 did 20.2. So that's a good way of laying out your information into something that you're visually familiar with. Determine the domain and range of the relation. So what's the domain going to be? Is it going to be the teams or is it going to be the jumps? The teams. This is our domain. So my domain, we do this cool little squiggly. It's just going to be 1, 2, 3, 4, and 5. Okay, you're just listing the X values. And then our range is going to be their jumps. So to list the range, we're going to list the jump distance. So we're going to have 20.6, 21.5, 20.9, 19.4, and 20.2. So when it wants you to list the domain and range, literally just list the numbers out. Okay, just the x's for your domain, just the y's for your range. Because now, since they're separated, which one of those am I going to focus on to answer the question about if it's a function or not? Just the domain. Okay, so look at just the red up there. 1, 2, 3, 4, 5. Did anything repeat? No, no team jumped more than once, right? They all only jumped one time. So is this a function? Yes. Yes, it is a function. And again, we focused on just the domains. Sorry, these notes are so tiny. If you have extra paper in your binder, you're always welcome to obviously use that, and you can like staple them together so you know that they go together. Or if you need paper from me, I can give you some. Want to do one more with like words? Let's do one more with words. Any questions on the long jump before we go into height? Okay, here we go. Excuse me. All right, we have Bailey recorded the heights of 5 of her friends. The heights in inches are as follows. Hunter is 62 inches, Ling is 66, Ella is 65, Omar is 66, and Alma is 67. Okay. Find the domain and the range of the relation. So let's start with domain. Okay, so the domain is, we have people and we have their measurements, right? My domain is going to be my people, my friends. Because I can't have a height if I don't have a person. Does that make sense? That's how I know that the domain are the people, X. X comes before Y in the alphabet, right? The person has to come before measuring the height. You can't measure someone who doesn't exist. So who are my friends? We have Hunter, Ling, Ella, Omar, and Alma. All right. Now it wants me to find the range of the relation. So the range is going to be their heights. So what was Hunter's height? 62. What's Ling's height? Ella. Omar. Alma. Okay. Is this relation a function? What do we think? Yes or no? What should we focus on? Focus on your domain. Did anything repeat in my domain? No, this one was tricky though, because what happened in the heights? I had 2 people the same height, right? 66 repeated, but that's okay. The issue is, and let's use common sense here. Okay, if I measured Caroline, right? Can I get 2 different heights for Caroline? No, that doesn't make sense. That would be if an X was used twice. That doesn't make sense. Caroline's height can't be 62 inches and also 64 inches. Doesn't make sense. Okay? Because Caroline's name would have been listed twice on my list. Right? That would be the problem. So looking at my domain, did any of my friends get measured twice? No. They did not. Okay? So is this a function? Yes. Each input had exactly 1 output. So each person had their own measurement. All right, what time is it? Good time. So that was all about determining if it's a function or not based off of actual data given to you. My next piece is we're going to look at graphs. Okay, so on the front, what did we say what test are we going to use to determine if my graph is a function? Start with a V. Vertical line test. Yes, we're going to do my graphs past the vertical line test. All right, so look at those. Do any of them stand out that definitely won't pass the vertical line test? The first one for sure, right? That's kind of what I use as an example on the front. Yeah, my first one, definitely not. If I drew a vertical line, it's touching twice, right? So right here, this is a no. It fails. It is not a function. How about lines? Do you think lines are functions? We use them all the time. Yes, lines are definitely functions. If I drew a vertical line anywhere on this, it's only going to touch it at one spot, right? So yes, lines are functions. This is a yes. All right, how about that wavy looking one going sideways? No, why not? Where did you draw a vertical line and it touches twice? If I draw vertical lines, this guy, the sideways wavy guy. I forget if this is cosine or sine. It's one of those. This is the graph of either cosine or sine. This is a function. Yes, this one passes. We're good. Okay, so what if that wave is going up and down? See, now it fails. Because if I draw a vertical line, let's say, I don't know, the y-axis, isn't it? I mean, it's crossing at a lot of different points, right? So this one fails. No. Do you think quadratics are going to be functions? X to the power of 2? Didn't we just do some of that? Maybe we didn't do some of that. The answer is yes. Anything that has an f and an x is as an equation, or an x and a y, same thing. It is a function. Okay, now we're going to work with equations. Okay, I'm actually going to go down here to pools. I want to do this one first, and then we'll do the other ones. So we have a swimming pool that holds 10,000 gallons of water. It is being filled at a rate of 600 gallons per hour. The function h of x equals 600x represents the amount of water in the pool after x hours. Okay. Part A says find h of 3.25. So I want you to look at what happened here, because my function was written as h of x, right? But now this says h of 3.25. So what's different between h of x and h of 3.25? What got switched out? The x, right? I still have h, but my x got switched out with 3.25. So what do you think we're going to do in the actual equation? We're going to switch out the x. So instead of 600x, we're going to say 600 times 3.25. The x got switched out, so we're going to switch the x out in the actual function also. So when that x changes to a value, it's showing you what to plug in. It's showing you your input. All right, so what is 600 times 3.25? Where's the calculator? Antonio, you got one. Caroline, you got one. What you got? Josh, you got one. What is 600 times 3.25? $50? Yes? Does it match? Does it match? Awesome. All right. Sweet numbers. What do they mean about this pool? What does 3.25 represent? We're filling up a pool, and it takes hours to do that. So is 3.25 the hours, or is it how much water? 3.25 is my hours. See how it says X hours also in my description? After X hours? So that usually is listed for you, so you know what's what. X represents hours. So since X changed to 3.25, that shows me that it has been 3.25 hours. Okay? So after 3.25 hours, there is a total of how many gallons? What did we just figure out? Yeah, 1950. 1,950 gallons of water in the pool. So that's what those numbers mean. It's showing after 3.25 hours of filling up the pool, we have a total of 1,950 gallons in the pool. So this is called evaluating functions. When we plug numbers in as like an evaluation, that's called evaluating. Okay, so we're going to do a couple more practices of evaluating. If you write big, this might be when you need another piece of paper, possibly. Yes. I need to finish first. Is anyone else writing this down? All right. We are going to evaluate f of x equals negative 2x plus 9 first. Okay, so see I have f of negative 6, f of 4, f of 5, f of 1. All of those x's are being changed to a different value each time. Okay, so my first one has f of negative 6, so I'm going to replace my x with a negative 6. So instead of 2 times x, it's going to be negative 2, come on, times negative 6 plus 9. So you're literally changing the x to a number. And usually when this happens, you'll notice we always do parentheses around what we're plugging in. Give it a second. It'll come back. What is negative 2 times negative 6? Almost. Positive 12. So that becomes 12 plus 9. I'm doing order of operations now. So I'm multiplying. And then what's 12 plus 9? 21. So when we plug in negative 6 into my function and we evaluate it, we get an output of 21. All right, part B kind of has two things happening, right? I have f of 4, but then it also wants me to add 3 to the end. Okay, so let's do the f of 4 part first. F of 4 means I'm going to take negative 2x plus 9 and make it negative 2 times 4 plus 9. And then this plus 3 on the end, we're just going to add 3 to the end of it. We'll wait for it. There it is. If you're a visual person like me, this is when colors would be super helpful. Okay, and from here, again, order of operations. So we're going to multiply first. What is negative 2 times 4? It is negative 8. We still have plus 9 and plus 3. Careful, negative 8 plus 9 is 1, and then 1 plus 3 is 4. So we plugged 4 into the function, which came out to be just a 1, and then it wanted me to add 3 on the end of that. This next one wants me to evaluate twice and then subtract them from each other. So we're going to do one piece at a time. Let's do f of 5 first. So right below it, I'm going to do negative 2 times 5 plus 9. What is negative 2 times 5?
Negative 10.
Negative 10. And what's negative 10 plus 9?
1.
Negative 1. Good. So that's one piece. And now we're going to subtract from that. Let's do orange. F of 1. So I'm going to do it again, but my x now becomes a 1. So instead of negative 2 times x plus 9, it becomes negative 2 times 1 plus 9. What's negative 2 times 1? Negative 2. Good. And what is negative 2 plus 9?
Negative 1. I mean,
It's okay. 7. So f of 5 was negative 1. F of 1 became 7. So now we're going to subtract them. What is negative 1 minus 7? Negative 8. So we can say f of 5 minus f of 1 equals negative 8. That's another way you could write your answer also. This is what you told me to do, and this is what I got out of it. Okay. We're going to stop there for today. I want a chance to stamp your papers. So this last little piece, it's just like what we just did, but see how the function's a little different? That's called a quadratic, okay? So we can start with that tomorrow.